nowadays, most people think nothing about climbing into a jet airliner and flying across the world. And it really is a very easy thing to do. But it's also true to say that the airline routes that are flown around the world had to be opened up. In other words, they had to be flown for the first time. Now in 1919, quite a momentous event occurred. Ross and Keith Smith flew an ex-RAF World War I bomber all the way from England to Australia. Now the Vimy was a very interesting aeroplane. As I said, it was a bomber during World War I. And it had long range, it had twin engines, although the Rolls-Royce Eagles with which it was powered were liquid-cooled engines. They weren't particularly reliable. If you were lucky, you got 100 hours before something broke. But it would fly quite happily on one engine, lightly loaded. And it seemed to be ideal for the flight. Now, the impetus for the flight was given by the fact that the Australian government offered a prize of £10,000, which in today's money would be about $1 million or perhaps a little more, to an Australian crew who flew their aircraft from England to Australia. And with Wally Shears and Jim Bennett, who were both mechanics, they were able to take off, and in 27 days and 20 hours they covered the 12,000 miles from England to Australia. Now it was an epic journey, and next year is the 75th anniversary of Ross and Keith Smith's flight to Australia. A gentleman named Lang Kidby. And along with Peter McMillan, they've decided to recreate Ross and Keith Smith flight, and also the flight of Alcock and Brown across the Atlantic from Newfoundland to Ireland during 1994. Now in order to do that, they have to have an aircraft, of course, and they've decided to build a full-scale replica Vimy from scratch in order to do these flights during 1994. The project is called Vimy 1994. The aircraft is being built partly in Australia and partly in America. They've contracted Wayne Daly of Aircraft Engineering at Browns Planes in Brisbane to build the fuselage, which is a chrome moly steel truss structure, which has been designed by Bill Whitney. Now, Bill Whitney is a very prominent Australian aircraft engineer. He has been responsible for the design of the replica of Kingsford Smith's Southern Cross, as well as other aircraft such as the Australian Lightwing and many others. And Bill checked out the original Vickers drawings from England and found them to be very, very structurally strong. He's made a couple of minor modifications to the airframe, mainly in the replacement of the aft fuselage area with steel tube instead of a wire-braced wooden structure. But the rest of the aircraft remains virtually exactly as it was designed by Vickers in around about 1916. The only major departure from the original is in the fitting of a pair of specially modified 454 cubic inch Chevrolet V8 engines in place of the Rolls-Royce Eagles. Wayne Daly, who is also carrying out the modification of the engines using the very best available forged connecting rods and crankshafts, best available in the world, and setting the engine up so that it comes on torque at around about 4,000 revs per minute. And it is also, the huge propellers are being reduction driven by a gearbox, an epicyclic gearbox, which is also designed by Bill Whitney. Lang, what was the original inspiration for the overall project?
Well, it started back in 1990 when I ran an antique aircraft rally, England to Australia. And one of the more competent pilots on that rally was a young stockbroker from San Francisco called Peter McMillan. Peter and I became good friends, and he was visiting just before Christmas last year, and we were talking about the pioneers of aviation and thought that we could run a project that would commemorate some of the efforts of those pioneers. We looked at all the various flights that had been done, and the one that really stood out was the Vimy. We looked at the calendar, took a deep breath and said, we're going to do it. And that's where it started, and we haven't stopped since.
What did the calendar tell you?
That we had about half as much time as we really needed, but we've got to do it by the middle of 1994, so it gave us something less than 18 months to build a huge 6-ton aeroplane and find the person who could design it, find the people who could build it, test fly it. That was a major project, but our confidence was such that we think we will make it.
Bill, tell me about the structure of the Vimy. How close to getting it right were they back in 1914 or 15 when it was designed?
Very close. We've reanalysed it against the modern design standard FAR 23, the American standard, and we've had to change very few things structurally in the aircraft. We have made some changes in the rear fuselage, but that was not for reasons of shortcomings in the basic design, it was just for ease of manufacture.
So you converted it from a wood fuselage to a steel one?
That's right, a wooden truss, diagonally wire braced to a tubular steel truss, yes.
Labour intensive?
The original one was, yes, very, very labour intensive.
Well, I guess that structural strength is borne out by the fact that these aircraft opened up the world's airlines routes as we've already established.
Yes, that's right. They worked very well structurally. They were reliable. I don't know of any problems that was ever had with the structure. Really, it's just like a couple of tiger moths strapped together. The Tiger was very, very reliable, and this structure was very reliable.
Bill, do you have a sense of history when you delve back into the soul of an aeroplane such as this?
Absolutely, yes. No question. I've been down this path on a couple of occasions now, and it is very rewarding. You can see from the old drawings how it was put together, and also you stand it up against the modern design standards, and then make the fine changes that you feel that are necessary. But it is certainly a very, very exciting project.
What about detail design, Bill? I noticed that you've done away with wooden cabane struts and gone to an aluminium one.
Yes, that's right. We made the struts from aluminium to cut down the weight and the labour involved. And one of the things that I take back to Wayne was he was talking about the drawings. I'd point out the whole aircraft was drawn on computer and analysed on computer, so that you can be very, very certain that when the things come together they match. And one of the things that we do with our company, one of the sidelines of our company, CAD Partners, sell these very advanced computer packages, and these very advanced packages reduce enormously the amount of drafting time, and also lift the level of certainty of things coming together to a much higher level.
Okay, what we have here is a full-scale template of the airfoil section. This template is fabricated out of aluminum plate, and it serves pretty much as a guide for running the bearing on the router to cut the actual profile for the ribs. Here's an actual rib profile for a compression rib right here. It was cut on this template, the center section of the template right here. I'm going to show you here how we accomplish that. We're going to simulate, well, we're actually going to cut a nose rib right here on the nose rib template. Pick the tool of choice. Take a little sanding block, sand the piece down. Now we have the nose rib.
Well, Wayne, we've been talking about doing an awful lot of flying, in fact circumnavigating the world and doing a lot of shorter trips in the meantime. You're the man who's handling the power units. Tell us about them.
Basically they're just two big block Chevrolet engines. They have a lot of high performance componentry. The only real standard part is the cylinder heads and the cylinder block. Every component that we put in there far exceeds anything that the engines will ever have to produce.
Now, the interesting thing about it is you're used to building performance engines which are required to turn at high revs and develop as much power as it's possible to wring out of a piece of machinery. These engines are exactly the opposite, aren't they?
These engines are designed for a much lower RPM and torque factor than what we're used to building, yes.
And obviously the engines are going to be stressed way under their normal limits.
They will never reach the limits that we would expect that they could reach if they were put to the test. Yeah.
Now, they're big propellers. Obviously you have to reduce shaft revs to propeller revs. How's that being done?
Bill has designed a 4-to-1 reduction gearbox, which we are also building in the factory, along with the help of Fesco Pilots, who are producing the gears and the heat treat. We expect those to be finished in the next 6 to 8 weeks.
Bill, tell us a little about the gearboxes. That really is a big engineering job.
Yes, and as far as the project is concerned, my view is that is the area that does contain some risk, and we'll be doing our absolute best to minimise that risk. They're 4-to-1 planetary systems. They were designed by myself with some very able assistance from a man called Ted Baker, who lives in Campbelltown. And we're using the very latest steels, vacuum degas steels. It's a very simple planetary reduction. It just sits in a bath of oil. One of the key factors in the design of the planetary is to isolate the propeller and the reduction gearbox from the engine, and we do that by using a tuned rubber vibration damper between the two, so that the first natural frequency of the drive of the engine lies below the operating range, so you get damping above it.
So you don't have those torsional problems of breaking crankshafts that have been known to happen with some aircraft?
That's certainly the plot, yes. We're confident that that will happen. In fact, I have some previous experience in this area with the Bristol F2B replicas. We used the very similar engine, the same damper, and they worked very, very well indeed. So we're quietly confident that it'll be fine. But we will thoroughly bench test it before we commit it to flight.
Bill, we've established that the original aircraft was structurally soundly designed. What about aerodynamics?
Well, the aerodynamics of the aircraft will be interesting, but I don't think that it will have any vices. It's a biplane. Both wings are exactly parallel. There's no difference in incidence between the two wings. That being the case, the upper wing will carry more load, will therefore stall first, and so there should be a gradual stall on the lower wing. All biplanes have this characteristic, that are designed that way. It should be longitudinally stable, it should be directionally stable, and it should be laterally stable. All reports would have it that it was extremely heavy in roll. In fact, the pilots will have to develop a whole new respect for the rudder pedals, and all turns will be just definitely rudder first, with just a little bit of aileron to help things even up.
And then plenty of opposite aileron.
Yeah, we had the same problem with the Southern Cross. The pilots hated flying it to start with, but then in the end, once they thickened up their thigh muscles and calf muscles, they loved it. So it's just a matter of really relearning how the old flyers flew. And once you've done that, well then that's fine.
Yeah, so we're not saying it's dangerous, we're simply saying that it's different.
Correct.
It came along before the years of refinement of aerodynamic qualities in aeroplanes. In fact, I would imagine that this would be an extremely stable aeroplane, which does not make a very pleasant to fly aeroplane.
I think it's stable. No, I think it'll be pleasant to fly. Obviously, you're not going to be doing aerobatics in it, but for normal flight, I think it's fine. It's just that the pilots are going to have to relearn their use of the controls, or shall I say, modify their use of controls. The use of the controls, of course, is normal, but they're going to have to really learn how to use that rudder pedal again. Other than that, we have reports that it was capable of flying on one engine, and we will have best part of, I think, 80 horsepower more now, won't we?
Yes,
something like that.
correct, yeah.
With the same sort of prop, it'll be slightly coarsely pitched, so we will have more thrust available.
So, and the aircraft will be considerably lighter, won't it?
The empty weight will be, yes. Yes, the engines are much lighter. I don't quite remember what it was, but they are certainly much lighter. The rest of the structure will be pretty much the same. We will be covering it with a Dacron-based fabric rather than the old cotton, so that'll be quite a deal lighter as well. The basic structure of the wings is virtually identical to the original, so there'll be no difference there. And the fuselage is pretty much the same too. So most of our weight savings will be in the engines. We may have to fudge the engines forward a little bit to get the weight and balance right.
And you're actually making up for that weight saving by installing more fuel in the aircraft.
That's right, we'll lift 6,000 pounds of fuel.
Tell us a little bit about the fuel tanks.
Well, the fuel tanks are designed to fit very neatly into the fuselage. We've really got to put a lot of fuel in that fuselage. And they're a riveted construction, which is complicated and expensive, but I used that technique on the Southern Cross and it works, so that we don't have that technical risk. They're very deep, they're 42 inches deep, so the pressure at the bottom of the tanks is is quite a deal higher than it is in a normal tank. And when you put the load factor of the aircraft on top of that, then yes, the fuel tanks are technically complicated and require care and attention. And of course, they're scattered all the way along the fuselage, so there'll have to be a very definite burn-off sequence to keep the centre of gravity in the right place during flight.
So fuel management will be very important, Lang. I want you to remember that.
Well, we'll be paying particular attention to the weight and balance of the aircraft. I think one thing that you must remember, when this aircraft was first built, the pilots had very, very little experience. The engineers, their aerodynamic knowledge probably wouldn't be all that much more than a private pilot would have today. Their engineering knowledge and construction knowledge was very high, but we have so much more theoretical knowledge than the fellows who flew this back in 1918, 1919. I feel sure that if they could fly it, we, with our current knowledge and experience that both Peter and I have got flying, we should make a fairly good fist of keeping the thing right side up in the air during the test flight and then onwards.
I might add, if I can just chime in on that, we analysed the aircraft using finite element methods, computer-based techniques, which are extremely advanced. So we probably really know far more about the structure than the original designers did. And of course that enormously shortens the analytical time taken in the analysis of the fuselage.
So the difference between you climbing into this aircraft and its original pilots is just huge.
It certainly is. I think we've got ourselves a little bit technical and a little bit serious in this day and age. The flight manual for this aircraft consists of about 4 paragraphs saying something like the aircraft flies very similar to an Avro. You should hold the nose up and don't do gliding turns near the ground, and that's it. That is the flight manual. If this aircraft was produced today, we'd have a flight manual of 100 plus pages.
Yes.
The fellows seemed to do quite okay in those days, possibly because I didn't know what they were letting themselves in for.
Ignorance was bliss.
It probably was, but as I said before, with our extra knowledge now, we'll be able to avoid a lot of the pitfalls that they may have avoided through sheer luck rather than good management. And hopefully we'll avoid putting ourselves into situations where they finished up just because they didn't know exactly what was happening with the aerodynamics of the aircraft. But apart from that, I think they did a marvellous job, and it wouldn't hurt to adopt some of the attitudes that they had in those days.
Absolutely.
Hi, I'm Peter McMillan, and this is John Lanou, and we're here to show you a little bit about our construction facility here in the town of Sonoma, where we're building the wings for the Vickers Vimy. And this is John. He's a very experienced craftsman and master carpenter, and he's undertaking this great project. And so, I guess, John, you're going to tell us about what we're doing today?
Sure. Anyways, you can have an idea here of what kind of space we're working with. Unfortunately, we were able to obtain a facility large enough to fabricate this airplane. Right here we have blueprints that are actually our drawings for the aircraft. These drawings were done by Aeronautical Designs Australia. What we have here is a test section that we constructed. Initially, when we started the construction of the aircraft, we decided that we might want to work out some of the problems in assembling these large sections prior to actually working on the real piece. So after we've constructed our templates, we fabricated some ribs and some spars out of just some scrap materials so we could work out the assembly procedures. You can sort of get an idea of what kind of structure we're working with here. This is just a very small portion of like a section taken out of the upper center section. Some of the problems we were anticipating having was the fabric covering of the aircraft, considering we had a certain amount of under camber on the wing here. As you can see, if we can get the camera down just a little lower here, you can see the under camber. It's not a flat surface on the bottom of the wing, and it has this concavity to it here. So anyways, the test section sort of offered us an opportunity where we could work out some of the problems in dealing with the fabric covering. Because of the under camber, we're going to have to rib stitch the entire wing.
The undercamber actually was just, it's a credit to the fact that when the wing was designed, RAV-15 airfoil in 1917, they really didn't understand, they didn't have any sort of testing facilities, and they really believed that they were actually getting more lift by creating an undercamber, which actually really only makes a less efficient wing, but in fact we really can't design that out of it because that would sort of change all the individual points of lift and the authenticity of the airplane as well. So that's why, although it's a little bit more of a hassle, you know, we're going to stay as much as original as we possibly can.
It's surprising. We've only set up this shop about a little more than 6 weeks ago. And the first 2 weeks we spent just tooling up, and so we've actually only been working on the airplane itself for about 4 weeks.
That's amazing.
And yeah, we're putting a lot of hours in it, but enjoyable hours. This is a very exciting project to work on, and it feels really good to be part of some kind of historical event. This is our spar laminating press that you see right here. And what it does is it provides the clamping pressure for our spar caps. Spar caps consist of several different layers of material that have glue between their interfaces.
They're in there now, aren't they?
Yes. Well, these are just some ones that we actually glued together yesterday, but just for the sake of this demonstration, we're going to leave these in here. Once the wet laminations are placed in the press, we take these safety devices, clamp over the top of the movable fence. Dan, sir. Once the safeties have been applied to the press, we will energize the fire hose that runs down the entire longitudinal axis of the press. We'll inflate the fire hose. This is a 3-inch double-jacketed fire hose. We'll inflate it to 65 to 70 pounds of pressure. The fire hose itself is tested to about 300 pounds, so we're well within the safety limits of the hose itself. At this point, I'm going to throw the valve here and inflate the hose, which will provide the clamping pressure for the laminations.
Lang, this is obviously a huge project. I would regard it as being one of the last great adventures. It must inevitably have a high profile with media all around the world. What about funding?
At the moment, the aircraft is being funded by Peter McMillan himself. He has shown fantastic commitment to this project, and he has funded this up to this stage. It's a rather large project. It's something approaching $1 million to finish the whole aircraft and do the flights. We're getting some very, very good response from some large companies around the world. Just recently we had a very, very happy meeting with National Geographic, and National Geographic have adopted this as a major project for their organisation next year, and we now feel that an organisation with such a good name as National Geographic behind us, we should have minimum problem convincing a sponsor that this is a worthwhile project. Apart from the historical point of view, we believe that we can offer good commercial returns for someone who will back us in this project.
How would you actually provide those returns? I mean, apart from printed matter, would it be possible to sign write the aircraft?
Yes, limited sign writing in keeping with the style of the aircraft. We want to keep the original colour scheme of the aircraft, but there is no problem with the sign writing going on the aircraft in a subdued manner. Obviously, everywhere the aircraft goes, there'll be huge press coverage, and sponsors will be able to take full advantage of that. And the crews themselves will be able to contribute any time that they were not involved with the flying. There's documentaries planned for the aircraft and for the journeys, which will be seen by millions of people around the world. And National Geographic, of course, is read by 40 million people. I think there's 200,000 subscribers in Australia alone.
Wonderful.
So we're hoping this is going to be a very high profile event and give due credit to the Smith brothers and Alcock and Brown, who were really the founders of long distance air travel that's so commonplace today. We're very, very pleased that Australian aviators have been given their due. The Smith brothers are really not well known. Kingsford Smith is extremely well known all over the world, But the flight of the Vimy, when taken in overall context, was much more important than Kingsford Smith's flight across the Pacific. No one believed that aeroplanes could fly such a long distance. The Smith brothers did it, and it was such a significant aircraft for Australia. I'm very pleased that Peter and I agreed to do this particular flight.
As you can see here, we have a dedicated crew, and we've engineered our way through some particular problems that haven't been seen since 1917. So we're optimistic that certainly by sometime in the latter part of the winter, we'll have the wings up and the fuselage will be here from Australia, and we'll be building an airplane right here in this very room. Right, John?
We sure will.
Okay, Dan.